All right, good Friday morning, everyone. I hope you had a happy Ramadan and Baisakhi this week. Baisakhi is the Sikh and Hindu solar new year, which took place on April 13th. Today's episode is about bees, in particular honeybees, which are not native to our backyards, but certainly exist in and visit our backyards on a regular basis. This is also one of those monster topics where stories could fill entire seasons based on the social and behavioral complexity of bees and their long association with humans. So I'll try to avoid some of the more basic and well-known facts that are easy to look up and focus on some of the more intriguing stories that bees have to tell. But even I was surprised at how much I had to leave out of this episode. I'd like to send an extra special thank you to subscribers who keep this community running every Friday morning, and to members of the Urban Ecology Center who have some nice things to look forward to in April. On April 27th at 10 a.m., you can join in a virtual members-only coffee with the one and only Terry Evans, pictured here, branch manager at Washington Park. Other than being a Pittsburgh Steelers fan, Terry is a nearly flawless human being, and I certainly cherish every opportunity I get to talk with him. Also, our friends at Hacienda Beer Company have some great discounts for UEC members, and all you have to do is let your beer tender know you're a member. I also got my feet wet in the podcasting world. So if you listen to the latest Urban Ecology podcast, I sit down with a couple of the stellar members of the UEC's community programs team about the importance of community and education. I'm also excited to highlight that the UEC has some great Earth Day centered volunteer opportunities during Earth Week, including a garlic mustard pull combined with a garlic mustard pesto making session. Conservation combined with culinary delights just doesn't get any better than that. So check out the events on our website. And Aaron Whitney posted a great garlic mustard pesto recipe on the UEC in my backyard. So if you can't make the live program, you can check that out. And I'm also super excited for a hybrid Brew City Birding Festival. We've got a week of virtual and live programs, including biking and canoeing, drawing workshops, some great virtual programs, and that culminates in the Backyard Birding Blitz. So please visit our website or talk to anyone on the research team for more information. More signs of spring are happening. Chad the Nature Dad said in a recent meeting that his neighborhood is filled with the sounds of lawnmowers now. Daffodils are up, more birds are singing and woodpeckers drumming, peepers are peeping, and on the night of April 21st, the Lyrid meteor showers are at their peak, emanating from the constellation Lyra the Harp, and ending that January to April meteor shower drought that we experience, at least here on Earth. So if you want to look for them, go out after the moon sets, anytime from April 16th to April 25th, again with the peak on the 21st. And for a couple more signs of spring, we'll go back to an old favorite here, Chad the Nature Dad, for this week's short trailer. He's out with his daughter Kendall in their neighborhood haunt. I assume it's Seminary Woods. And although you'll notice from Chad's hat and jacket that winter still has a little bit of a strong grip on this area. So here we go.
Hey friends, Chad the Nature Dad here. Doing a little exploring, finding out what's starting to pop up here in spring. I was looking for some salamanders, and little did I know I was going to find something super cool. Let's check it out. All right, so flipping up this log, and I saw a whole bunch of this metallic green insects in here, and I believe these are some sweat bees. And accidentally, when I lifted up this log, the bark stuck to the ground. That's when I saw these little ones in here, those sweat bees. And then I looked into the log and I noticed all the holes, and this must have been their winter hibernating place. So they just hunker down here all winter long. I don't know if they're hibernators or not, but they hunker down here for the winter. And then once it gets a little bit warmer, they're going to start coming out and probably be some pollinators, maybe even for that skunk cabbage we found next time. Yeah, so cool. A lot of insects and animals hibernate inside logs for winter, and sometimes you get to find them. Hey, Kendall, you're out here in the woods with me again. Awesome. And you found something cool too, didn't you?
Yep, I found wild onions.
Ooh, some wild onions. Let's check it out. Show us some. Hey, Kendall, looks like you found a good one right there. What's your technique for getting out the onion in the bulb? Well, that's all right. The leaf does a part that you want to eat. So, what do you like about wild onions?
I
You just like onions. You like them because they're spicy? Yeah, a little bit spicy. So these wild onions, they are growing all over in most of the woods. It's cool if you want to pick a couple and enjoy some, but please don't pick them all. Otherwise, we won't have more wild onions next year. But yeah, they go great on mashed potatoes or maybe in some pizza, on top of pizza. So they're a great tasty snack in the spring. All right, friends, this has been Chad the Nature Dad, and
Kendall.
oh yeah, exploring some more signs of spring. Join us next time. Who knows what we're gonna find?
All right. Thanks, Chad and Kendall, for that timely episode. And now it's on to the feature presentation brought to you today by the Honeybee. I'd like to reference some of my usual sources, the folks at Stuff You Should Know and How Stuff Works Machine, and Ologies with Ali Ward, interviewing melittologist Amanda Shaw. And a big hug shout out to my friend Charlie Keenan, the bee evangelist, who over the years has taught me so much about honeybees and helped coordinate a wedding present of a top bar hive given to us by our good friends working at and involved with the Urban Ecology Center. In season 1, we featured the yellow jacket wasp in the episode Full Yellow Jacket. And for that, we focused on the evolutionary history of bees and wasps. So we won't talk about that today. You can revisit that episode. But the story starts about 100 million years ago during the Cretaceous period, when a carnivorous crabronid wasp that could have looked like this one raised a brood of young, and one of those wasps became the ancestor to a new lineage, which we call the bees. So bees are indeed a type of wasp. And in the Yellow Jacket episode, we also get into the coevolution of bees and flowers. But briefly, before bees, wasps were carnivorous and trees were coniferous, utilizing the wind to disperse pollen for fertilization. Then over many generations, bees started specializing in eating pollen and nectar rather than animal flesh, while also providing more reliable pollination services than the wind for what were to become the angiosperms, or the flowering plants. And bees and flowers have been working together ever since. In fact, it's one of the reasons that bees are so widespread in the world, because wherever there are flowering plants, there's almost always a bee to help pollinate them. The group that we call bees are a grouping of seven different families in the order Hymenoptera, which includes ants and wasps. And the subgroup of bees is known as Anthophila, but you can just call them bees. There are over 20,000 species of bees in the world. And they're divided into the solitary bees, which is the largest grouping, which includes mason bees. One of my favorites that I think might be a future Backyard Naturalist episode if we focus on native bees. There are leafcutter bees, which we see signs of all over the place in the summer. They use their mandibles to cut out leaf parts, which they then use to line their nests. There's carpenter bees, which straight up bore holes in raw wood, so you got to give them credit for that. There are mining bees, plasterer bees, which line their nests with a unique sort of drywall-like compound, kind of like a mortar. There are carder bees, which I love because they go out and collect the soft, fuzzy parts of plants to create a soft, cushy, cozy lining to the nests, kind of like if you've ever seen mullein, those leaves, which some people call nature's toilet paper, they have that nice soft fuzz. And the sweat bees that Chad found in the tree trunk, like this one that's eating like a 1-year-old that just doesn't care. So you might be saying, wait a second, there were like, I saw a half dozen sweat bees in that trunk that Chad popped over. That's not solitary, but you'll notice that each little hole had only one bee. So they were congregating in that trunk, not because they were in a colony, but because that particular trunk was really good real estate for overwintering. The sweat bees are the most common type of native bee in North America, but so many of them are tiny that we don't recognize them as bees, and a lot of others are mistaken for wasps. The social bees only make up less than 15% of all bee species, but include some of the most well-known bees, like the bumblebees, the stingless bees, and our honeybees. I do have to admit, however, that I have a new personal favorite bee after doing the research on this episode, and that's the two-colored mason bee, which is a solitary bee that builds its nest in empty snail shells, not to live in like hermit crabs, but to raise a family in. So after a female finds a suitable shell, she gets to work on the interior. She partitions the cavity into about 4 or 5 rooms or compartments. She furnishes each compartment with an egg and pollen before sealing them off so that when the eggs hatch, the growing larvae have their food for them and protection in the shell before they metamorphose into adults. But after she finishes building the rooms, she then sets to work camouflaging the shell itself by covering it with grasses and sticks to hide it. All this work for kids she'll never meet, but good for her. Smallest bee in the world is Trigona minima, or the dwarf bee, which is a stingless bee that measures less than 2 millimeters long. And while it looks pretty substantial in this picture, let's take a look at what 2 millimeters long actually looks like. So this bee is slightly bigger than the point of a pencil, but smaller than a tip of a new crayon. So pretty darn small. And if I were to give you a more realistic picture of what this bee would look like, you wouldn't be able to see it. They're that tiny. This would be a little more realistic. The largest bee in the world is Megachile pluto, or Wallace's giant bee, seen here compared to a regular bee, a honeybee, the Western honeybee. This bee has only been seen on a few islands in Indonesia, and it was believed to be extinct until 1981 when a few specimens were discovered, but then no more were found until 2018, just a few years ago, when 2 specimens were collected and then dutifully sold on eBay. And then a year later, a live female was filmed for the first time in 2019. But in any case, it has a 2.5-inch wingspan, which if you think about it, that's the diameter of a baseball. And so if you were holding one in your hand, and they do pack a nasty sting, so I wouldn't advise it, but if you were holding it in your hand, the wings would reach from one end of your palm to the other. As a group, bees feed on both nectar and pollen, unlike their flesh-eating wasp relatives. Nectar, the liquid produced primarily to attract pollinators, is a source of carbohydrate-rich energy, and pollen, which is essential to plant reproduction, is a source of protein and other nutrients, and is the primary food that bees feed to developing larvae. Honeybees belong to the family Apidae, which includes some of the most important pollinators for both natural habitats and agricultural crops. And this group includes the other social bumblebees and stingless bees, as well as the solitary carpenter bees I mentioned earlier, and a couple of new groups, the orchid bees, or euglossine bees, which have some really great stories and were used in a lot of the ecological studies. We discussed this one a lot in my tropical ecology class. And then the cuckoo bees, which just like the cuckoo birds are parasitic. They lay their eggs in the hives of other species of bees, which then gives the young access to rich food sources. So they sneak into a comb cell and they do kill the occupant of that cell. But after they do that, there's no further carnage. They're just mooching off the food in the hive. Out of the 20,000 plus species of bees, there are only 8 species that we call honeybees, and they're all in the genus Apis. And Apis is Latin for bee. The members of this genus are eusocial, which is the highest or most extreme level of social organization. To be eusocial, you have to have cooperative care of the brood. You have individuals taking care of young that aren't their own. You have overlapping adult generations. And most importantly, you have division of labor into several categories. So there's reproductive and non-reproductive groups. And then there's specialized behavior within those groups too, so that some individuals lose the ability to perform tasks performed by others. And those criteria are found in many ants, bees, wasps, termites, and even a couple mammals. There's rodents like the naked mole rat, and some shrimp. Honeybees have perennial wax nests, meaning the same nest is used for multiple years, just like a perennial flower lasts for multiple years, whereas other bees have annual nests, just like some plants are annual. And of course, honeybees produce honey in surplus for storage, which makes the hive a very desired target for many honey-seeking individuals. And humans have found many uses for beeswax and other hive products, which alone could fill about a dozen slides. There are other bees outside of the genus Apis that also make honey, including some stingless bees that frankly make the ideal honey producer for obvious reasons. In a 2019 UEC eco-travel trip to Cuba, our host Michael took us to visit his stingless honeybee colony in his backyard, and we all got to taste some honey without any protective clothing on or worries about getting stung, and it was delicious. It tasted very different from the honey we collect from our honeybees, the Western honeybee, but delicious nonetheless. And we're actually looking at this kind of from the, I guess you call it the bottom side. The really cool thing about stingless bees is that they produce some amazing patterns in their combs. But again, these are not considered the true honeybees. It's only the 8 bees in the genus Apis that are considered the true honeybees. And of those, none of them are native to the Americas. So they're not found in the history of indigenous nations here, although there are plenty of other bees here, but they weren't here at the time of European conquest. But one species is now widespread throughout the world, including North America, and has come to live in some of our backyards and visit probably all of our backyards at some point. And that species is Apis mellifera, or the Western honeybee. Mellifera is Latin for honey-bearing. And again, Apis is Latin for bee. So the name of this critter means honey-bearing bee. The anatomy of a bee and a lot of other information is very similar to the anatomy of a wasp. So I'm not going to kind of repeat the things that I did with the yellow jacket, except for where there are some key differences important to the honeybee story, which for recorded human history begins in several places around the African, Asian, and European continents where they originated. The honeybee is likely the earliest truly domesticated insect and shows up in early Egyptian history, both in that Egyptians cultivated bees for honey and wax and other products. In this depiction, people are making honey bread, and bees are also, of course, present in mythology. So according to one myth, the honeybees were the tears of the sun god Ra, whose left eye is shown here because the right eye is the moon. And in this context, according to the Northern Berkshire Beekeepers Association, the bee was seen as the messenger of the gods falling down like tears towards the earth to pass on important and secret messages. According to Planet Bee, bees were associated with royalty in early Egypt as early as 3500 BCE. Hives were made out of clay pipes stacked on top of each other and then floated up and down the Nile seasonally to pollinate flowers, much like modern day bee farmers load up semi trucks with beehives and transport them all around the country depending on the season. And it's truly amazing that this tradition of moving bees up and down the Nile still persists today and has continually persisted for more than 5,000 years, as has the practice of using honey to sweeten food and beverages, and to help heal wounds because of its antimicrobial properties, which they were already doing 5,000 years ago. Honey and wax were also used in the embalming process of mummies, and it is said, and I think it's true, I'm not sure if this is urban legend, that when King Tut's tomb was opened, a 2,000-year-old jar of honey was found inside. There are a lot of other stories. I'll tell one more from the San people in the Kalahari, which is a creation story in which a honeybee is carrying a mantis across an expansive desert, but exhausted, she realizes she's not going to make it. So she lands, lays the mantis carefully down, lays eggs in the mantis before dying, and then those eggs hatch into humans, and that's where humans came from. If we fast forward to the 1600s, it was still believed, even by beekeepers, that bees had a special divine power of spontaneously reproducing without sex. But in the 1660s, the Dutch biologist with the amazing name of Jan Swammerdam looked at a female bee in a microscope and found out that sure enough, bees do have sex organs, as do many of the other insects that were previously thought to possess some kind of magical power. I still think they do possess magical power, but maybe just not that kind of magical power. Fast forward another 350 years to today, and Apis mellifera is and has been a truly global species, prized for its honey, its wax, and its pollinating prowess. And there are many types of hives and cavities that people have used to help bees make the honey and to pollinate their plants. So we'll get into a little bit of the hive details. First of all, every stable hive has exactly one queen honeybee, the progenitor, the matriarch. You can pick her out in a crowd because she looks like a semi-truck among sedans. She's about twice as long as the worker bees. A queen only need mate once during what's called a nuptial flight. And after that, she will have all the sperm she needs for her lifetime, which can be up to 5 years long, which is really long for an insect. Her offspring will all live likely less than a year, even shorter if you're male, but the queen can live a long time. She is not, I found out, the only member of the hive who can lay eggs, but boy, can she lay eggs. She can lay up to 1,500 eggs a day, placing them each singly in a separate comb. Other workers do have the ability to lay eggs, but she releases a pheromone that prevents the ovaries of other females in the hive from functioning. And it's a common belief that the queen is in control of the hive, but this really isn't the case. The hive functions best and most efficiently when only one queen is laying eggs, which is at the heart of that eusociality. Individual workers seem to act in the best interest of the hive over their self, which, early on flew in the face of the Darwinian evolution, which focuses on individuals trying to maximize reproductive success, which is why so much work has been done on eusociality. But one way of looking at this is that it's in the best interest of the hive to keep the system running, and the system works best with one queen laying eggs. But to my earlier point, it's really the workers that are controlling the queen rather than the other way around. And there are situations where workers will kill the queen in the interest of the hive and start over with a new queen. When the queen lays an egg, she lays, as I mentioned, one egg in one cell. And when the egg hatches into a larva, it is tended to and fed by the workers. Once it's grown to its final larval stage, it's sealed off. And just like a butterfly, it spins a cocoon in the comb and metamorphoses into an adult bee. In the picture on the right, you can see various stages of larval development before the cell is sealed off. And after the adult bee emerges, just like a good kid, the first thing it does is it will clean out its cell so that the cell is ready for the queen to lay another egg. Anytime the queen bee lays an egg that she doesn't fertilize from her stored sperm, that egg hatches as a drone, or a male bee. Seen here, the slightly larger. It's bigger than female workers, slightly smaller than the queen. And essentially, drones have one purpose in life, and that is to mate. And if they are lucky enough to mate, it's a one-time deal. They don't get decapitated like male mantises or eaten like male spiders, but after mating, the female maintains a tight grip on his boy parts or the endophallus, and so that gets ripped from his body, which ends up killing him, much the same way that if a female honeybee stings a mammal, she will also die because her barbed stinger remains embedded in the flesh of the mammal skin and gets pulled out of her body along with some of her innards. But remember that only happens if a bee stings a mammal. If a bee stings another type of animal, she'll likely live to see another day because the flesh of a lot of other animals don't hold on to that stinger like ours do, like mammals. But back to drones, other than mating, they don't provide any help to the hive. They can't defend a hive. So when Charby's doing programs, he'll pick up a drone with his bare fingers to the astonishment of those watching, but he has nothing to fear from that individual because the bee stingers evolved from the ovipositor or the egg-laying appendage, and males don't have those. They don't lay eggs. So the males really do nothing, but essentially drain the hive's resources, which is why in late summer, if you've got a hive, you'll see that after reproduction is complete, the males are kicked out of the hive by the females, so that they don't use the precious resources that the hive will need to make it through the winter. So their free living, free loving, free loading lifestyle comes to an inglorious end, and they're kicked out in the cold to die. Any egg that is laid that the queen fertilizes will become a female bee or a worker bee, which is usually the majority of the hive. The role of a worker changes as she ages. It starts out, as I mentioned, cleaning out the room, and then it moves to childcare, tending to and feeding the other developing larvae. They feed them something that sounds delicious. It's called bee bread, which is a combination of pollen and nectar. Then later, her duties shift to cleaning and organizing the hive resources. And then later in life, they become a scout, looking for food or potentially new nest sites. And then finally, the last stage is that they become foragers. So the foragers are the oldest and most experienced bees. How bees find food is pretty simple. A scout essentially leaves the hive to search. They primarily find food with their excellent sense of smell, but they also look for color patterns of flowers. And often these patterns are hidden from human eyes if they're in the UV range. So this is all simple enough, but if they find something they think should come back to the hive, they'll bring a piece of it, and then she needs to let the hive know not only that she found the food and what kind it is, but where it is and how important that food source is, which is a process that is nothing short of amazing. They know the position of the food source relative to the hive by comparing an internal clock that takes track of time and compass, an internal compass, and they compare that to the position of the moving sun. If it's cloudy, it doesn't matter because they have polarized vision that can see right through the clouds to know where the sun is. So a scout comes back to the hive with a piece of food in its mouth, allows the foragers to taste the food so they know what it is they'll be looking for. And then it performs one of two types of dances to inform the scouts where they should go to find the food. I'm going to oversimplify this in the interest of time, but if she moves in a circle, pauses, and then circles back, this is called the round dance, and it means the food source is very close. It gives a direction to the foragers and a little bit more information, but because the food source is so close, there's not a whole lot more information they need to give. The foragers should be able to find the food source pretty quickly. If the food source is farther than about 50 meters away or half a football field, the scout performs what's called the Waggle Dance, which you've probably heard of, and there's much more information packed into this dance. So she'll perform it quite a few times in a row. The foragers will watch her quite a few times in a row to make sure they get the info right. But essentially, she'll run in a particular direction on the vertical surface that translates to the horizontal surface relative to the sun outside with a back and forth waggle. And for a particular distance, will translate to an actual distance outside, after which she will circle back to perform the waggle again. And the tightness of that circle indicates the quality of the food. And there's also likely information being conveyed in how vigorously she's flapping her wings and other behaviors during the process. Once the foragers, which are again the oldest members of the hive, have the necessary information, they'll go off to collect the food. They can fill their body with about half their weight in pollen and nectar. The pollen they pack all over their body, including grooves on the legs that allow the packed pollen to get bigger like snowballs. They have special tools on their legs to help them collect and pack the pollen. And it starts to get bigger like snowballs. And then the nectar they swallow. And so they bring it back to the hive, and they'll often take many trips, like a move often does. And then the hive starts to resemble this like a runway at an airport, with all the bees returning loaded with pollen. And one of the favorite parts I remember about owning a backyard beehive was setting up a lawn chair and just sitting right next to that beehive entrance and watching all the incoming bees loaded with pollen, and noting the color of the pollen on their legs, because that'll change based on what flowers they're visiting. Um, Look at what direction they're flying from, how often they're entering, which is kind of like sitting on Layton Avenue watching the airplanes fly into Mitchell International. Once inside the hive, another group of bees becomes the kind of the unloaders, and they'll pack the cells with the incoming pollen, and they'll also signal to the foragers whether or not they need another trip. So if they accept the food very vigorously, the forager knows, okay, they're excited, they want more, I'm going to go back and get more. But if they accept the food and they're a little more blasé, like, thanks, then they know they can probably take a break for a while because the storage space is getting full. And this is the storage space. So you can see on the lower right that some of the cells are being filled with pollen from different flowers. The cells on the upper left are capped brood cells or honey cells sometimes. And you can see a couple larvae in the cells. On the upper right, you can see that some are filled with the nectar, like the honey is forming. But nobody's collecting honey. So where does that come from? And I'll tell you that story, and hopefully I don't think I can ruin honey for anybody because it's so delicious. But if you don't want to know, turn down your volume for the next slide. So worker bees transform nectar into honey through a series of consecutive regurgitations, like a cow chewing its cud. Regurgitate, swallow, regurgitate, repeat. But every time they do this, the consistency of the nectar changes. The moisture level drops. It becomes thicker and more viscous, like the honey we know. And then once it's at the desired consistency, it's packed into the cell. But even after it's packed in, workers will still go around and fan the cells with their wings to continue that drying process. And there's a couple of really important things that happen. First of all, it's not only the consistency of the nectar that changes. They're not just taking nectar and distilling it. They're actually changing the composition of it as well. So it's distilled nectar with a lot of the added bee stuff that comes from the bee gut. So the bee adds nutrients and enzymes from its own body into the proto honey every time it ingests and regurgitates. One of those important enzymes is glucose oxidase, because it breaks down into glucose and hydrogen peroxide. And that's important because that helps give the honey really strong antimicrobial properties, which is why the honey lasted so long in King Tutankhamun's tomb, or why cultures around the world have used honey to help heal open wounds. It has fantastic antimicrobial properties. So part of that comes from the chemicals, the hydrogen peroxide, and part of that comes from the honey through that process gets a very high osmotic pressure, which means it wicks moisture out of the air. And so if a bacteria were to come in contact with it, it would wick the moisture from that bacteria as well, which then would kill the bacteria in the process. So those two things really contribute to the antibacterial, antimicrobial properties of honey. There is, however, one particular organism that is impervious to the honey's defenses, and that's Clostridium botulinum, or botulism. It's a naturally occurring soil-borne bacteria, so it easily makes its way into honey, and just about all honey has it. For most humans, the concentration is way too low to have any effect, so the botulism that we ingest just becomes part of that all-important diverse gut microbial community we've talked about. But it can be dangerous to newborn human babies, which is why they tell you to never feed a newborn baby honey. We'll have to talk about swarming and, frankly, a lot of other bee-related topics in later episodes, but I will share this photo from a recent New York Times that carried the headline, "A man found 15,000 bees in his car after grocery shopping." So this represents swarming behavior, and swarming can happen for a variety of reasons. Often happens because a hive is doing either too well and running out of space, or a hive is doing poorly. But essentially, workers make a new set of queens, and all babies, all eggs, all larvae are fed a little bit of what's called royal jelly. but only for a short period in their life. If they continue to feed the larvae the royal jelly, they will develop into queens. And they usually make a few queens that then go out for their nuptial flights and then kind of will battle it out for supremacy of the hive. And one of those queens then will, in swarming, carry about half of the hive off with them. How they determine half the hive, who goes what, is mind-blowing, but they first need a temporary home, like this man's car. I know our hive at the Urban Ecology Center Riverside Park formed a swarm in front of the tree right in front of the center. And they're in that swarm phase for a little while before they fly off to start their new dreams and their new home. But a couple things. First of all, this is when beekeepers love to be told about swarms. So if you see a swarm and you know a beekeeper, let them know, because this means that they'll usually have a hive at the ready. In Charbee's case, it's usually this little traveling box. It could just be any box. And they're able to get that swarm into the box and then convince that hive that their beehive is a good place to move into. And while it may seem counterintuitive that a swarm of bees isn't just outright angry, this is actually when they're at their least aggressive or most docile, because they don't have a hive to protect at this point. So, people will come into these swarms without any protective equipment and essentially just take the hive, put it in a box, and go home. Another really amazing things about swarming dynamics is that while they're swarming, there's scout bees that are out looking for new homes. And just like they do when they return with a good food source, a scout that's found a new potential place for a hive returns to the swarm with information about that location, and then they communicate that to the hive. But there are likely several scouts that are out finding new hive places, and they all return with these potential new sites. And so this is where bees are sometimes compared to sociocratic societies in humans. Each scout is kind of given the chance to vouch for their particular site. So they'll come back with the necessary information where it is, but they'll also convey how good they think that site is going to be for the hive. And that's probably tied to how vigorously they perform. And so if they come back and there's giving their information, but they're not doing it very vigorously, it might be an okay place. But if another scout comes back with information and they're just shaking and doing it really vigorously, the hive might decide to pick that place over the other one. So they moved to the place that had the scout with the best marketing power. So really complicated, but really simple at the same time. And that's also the thing about bee brains. They don't have big brains, but just like their social structure, they also aren't very centralized, like a lot of brains are. So it's kind of as if your mind were full of several kind of independent lines of thought for you to think about at the same time. And again, very complex as a hive unit. And really that's where the magic continues, which is one of the reasons why bees are so mind-blowing in their behavior, in addition to being so important for our natural spaces and our economies. So we'll end the talk with a short video that looks at some of the more important honeybee issues as they relate to humans. But I also do want to take a second to recognize that 1 year ago tomorrow, I and a small group of you got on Zoom on a Friday morning at the very beginning of the pandemic to talk about house sparrows together. And it was 1 year ago. I watched it a few days ago. And other than shivering at the production value and my many awkward pauses and the crazy state of the hair on my face, I did get a bit of nostalgia. And I'm really, really grateful for this Friday morning community that I've come to know over the past year. So happy anniversary to you. And thank you for enriching my life with your stories and your passion. So thank you. We'll see you next week. And I'll end again with a short video that looks a little bit at some of the conservation issues that I didn't really get into. And these are conservation issues that are different from the conservation issues of our native bees. So think about that as we play this video. But again, we'll see you next week. And here's the final video.
Hi, I'm Lauren, and this is Brain Stuff. When you bring up bees in conversation, do your friends inevitably start talking about killer bees and oh, how scary they are? Or do they make jokes about that awful Wicker Man movie with Nicolas Cage, all like, not the bees, they're in my eyes? Next time, tell them this. What we should really be worried about are where the hell all our bees are going. Since 2006, honeybees have been disappearing fast, and according to the USDA, too fast to guarantee their long-term survival. That's right, honeybees may go extinct. For all the jokes we've made about the worst fate of all being covered in bees, as it turns out, a world without bees is a lot scarier. Just this winter, 23% of the US honeybee population disappeared. Maybe you heard that and thought, so what about honeybees? I'm more like a honey badger, I don't care. But you should care, and here's why. The United States alone relies on the domesticated European honeybee to pollinate 1/3 of its food supply. We're talking apples, peaches, almonds, lettuce, broccoli, cranberries, squash, melons, blueberries, and more here, people. And I can eat like at least 15% of that, so please don't take it away from me. It's also like $15 billion every year in crops. So not only are bees crucial to our varied and delicious nutrition, they're also important to our agricultural economy. This record number of bee disappearances is referred to as colony collapse disorder. According to the USDA again, beekeepers are losing 30 to 90% of their hives every year. It's also called disappearing disease because it's not like we're finding little piles of bee corpses, they're just poof, gone. Worker bees specifically are the things that are disappearing, leaving behind the queen and some of the male drones. Like there's still honey in the hive, but without the worker bees, the colony eventually dies. The total effects of colony collapse disorder are staggering. We've gone from 5 million bee colonies in the US in the 1940s to only 2.5 million today. That's half of our bees vanished. And with our modern agricultural needs, hives have to pollinate more than ever before. If the losses continue at their current rate, it could threaten the economic viability of the entire bee pollination industry. The cost of honeybees and the honey they produce will rise, also increasing the costs of the foods that they pollinate. We won't starve, but we might lose some crops forever. The scariest part is that we can't nail down a cause for all of these disappearing bees. Researchers are looking at everything from pesticides to particularly cold winters or a scarcity of clean water as contributors. It could also be a whole combination of causes. On May 9th, 2014, a theory was supported in the Bulletin of Insectology. Researchers from the Harvard School of Public Health found evidence that a class of insecticides called Neonicotinoids were significantly harming bee colonies during cold winters, possibly impairing their neurological functions. These neonicotinoids are used to increase the stability of crops like corn. The European Union banned the most widely used of these in 2013 for a 2-year trial period, but they're still in use in America. Whatever the cause, honeybees are still disappearing at an alarming rate. If this army of bees that we've created dies off, what are we going to do? There are lots of actions that beekeepers are taking to try to save their hives, but trust me, there are way too many to list in this video. So we have posted them to our blog at brainstuffshow.com, so go check that out. I'd like to know what you think is causing all of these bees to disappear. So share your ideas with us in the YouTube comments or on our Facebook, Twitter, and Tumblr feeds. And hey, if you found this video informative and or entertaining, please subscribe to our channel to get more episodes beamed into your brain.
All right. And that's